Today we'll be taking the last topic of this chapter, that is the different equations of motion. So the derivation has been reduced from the syllabus. Now we only have the equations and the base numericals. So first equation is your velocity time relation, VT relation, and this relation is V equal to U plus AT. Here V is our final velocity, U is our initial velocity, A is acceleration and T is time. So this relation we can use where we are supposed to find the velocity of a moving object whose acceleration, initial velocity and time are being given to you. Now second is your position time relation. Position time relation, the equation is S equal to ut plus half at square. Here S stands for displacement, U again initial velocity, T is time, half a constant number, A acceleration and T square is your time square. Third is your position velocity relation. This relation is V square minus U square equal to 2AS. Here V final velocity, U initial velocity, 2 a numeric constant, A acceleration, S displacement. So let's have the denotations here. U is your initial velocity in all the expressions. V is our final velocity. A is acceleration. Now since acceleration, velocity, initial and final both are vector quantities, so you have to take care of their sign, whether they will be positive or negative as per the question. Then T is our time, S displacement, I believe all are done now. UV is done, acceleration, time and displacement. So these three equations we're gonna use while solving the numericals. So my dear students, you have to learn all these formulas, and these all three are quite important one from this chapter. So if you want to score full marks out of this chapter, these three relations must be on your tips and you should know which relation has to be applied where. So now we will be doing some certain numericals just to have more better understanding of these three equations. Just remember the equation and now focus on the questions. See, let's take an object which started initially from rest. So since the object started from rest, so U will be 0. Let's say object accelerates uniformly at the rate of 2 meters per second square. And this acceleration continues for 20 seconds. And you are supposed to find out the velocity. You are supposed to find out the displacement after 20 seconds. Right? So this is our question. Object starting from rest, accelerates at 2 meters per second square for 20 seconds. Find final velocity and find the displacement. So here we'll use the first equation, that is V equal to U plus AT, to get the final velocity after 20 seconds. So this V20 will be U, that is 0, plus acceleration is 2 into time, time is 20 seconds. So this gives us 40 meters per second. So this 40 meters per second is the velocity of the object after 20 seconds. Now we are supposed to find the displacement as well. So displacement using the second equation now. S equal to ut plus half at square. Ut factor will be 0 plus half. Acceleration is 2 and time is how much? Time is your 20 seconds. So square of 20 will be 400. Right? So this gives us displacement as 400 meters. So in this way we can apply the equation. Now what is required is that you have to identify that which relation will give us the answer. Okay, this was one example. Now let's take another example. Let's say this time an object has been thrown vertically upwards, alright, with a velocity of 60 meter per second. An object thrown vertically upwards with a velocity of 60 meter per second. Let's say you are supposed to find the height to which the object will rise. That's the thing only given to you. An object with initial velocity of 60 meter per second is being thrown vertically upwards and you are supposed to find the height. Now as we know, when the object, any object is thrown vertically upward, there is always one force acting vertically downward. That is your force of gravity. So acceleration due to gravity, whose value is known to us already, that is minus 9.8, or in most of the cases you can take it as 10 as well. If the question specifies that you have to take 9.8 only, then please do use 9.8. Otherwise, you can solve the questions with the value of 10 as well. Now, since you are supposed to find out the height, so third equation we can apply here. V square minus u square equal to 2as. V, final velocity at the highest point will be 0, correct? So that is 0 minus u is given to us 60. 60 square equivalent to 2 into a, we are taking as 10. So 2 into minus 10 into s. Now if I ask you why I have taken the value as minus 10. Reason is because when the object is going vertically upward, the gravity is always pulling it downward. So direction of acceleration is opposite to the direction of velocity. Velocity 60 meter per second is acting upward and your acceleration is downward. That's why acceleration is taken as minus 10 whereas velocity is your plus 60. Now to find out the s, it will be s equivalent to minus 60 square, that will be 3600, correct? So this will be your minus 3600 divided by 2 into 10 minus 20, minus minus cancel out each other, 360 divided by 2 which gives us 180 meters. So displacement in this case will be 180 meters. Right? Now there can be a mixed question as well. Mixed question means that there is acceleration and deceleration, both are occurring after certain interval of time. Let's take an example. Look here. Let's say we have certain distance between A to point B. An object starts from A from rest. So u at point A is 0. Then the object accelerates at the rate of 2 meter per second square for, let's say, 10 seconds. Alright, and it reaches point C. Then the object deaccelerates, that is minus 1 meter per second square, till its velocity becomes 0. Alright, I believe the question is clear. Let's repeat it. Object started from rest, accelerates uniformly at 2 meter per second square for 10 seconds, reaches point C, then it deaccelerates at minus 1 meter per second square till its velocity becomes 0. Now your question is, find out the total displacement. You're supposed to find how much object has made the displacement between points A and B. So we can divide the question in two parts, AC and BC. Okay, let's start to work on AC first. So for AC, initial velocity is given to us, that is u, which is 0. A is given to us 2 and time is given to us 10. So let's find out two things. One, what is the velocity at point C, and next, how much displacement has been done between A and C. So velocity, using the first equation, u here is 0, A is 2, time is 10, which gives us 20 meter per second. So this is the velocity with which the object will reach point C. Now for the distance, let's use the second equation now as ut plus half at square. Ut factor will be 0 because u is 0, half, acceleration is 2, and time is 10. 10 square will be 100. So we have displacement between A to C, that is 100 meters. Now let's talk point CB. Now for CB, initial velocity will be the final velocity of AC, that is U here will be 20 and A is given to us -1, and since the object has come to rest, so velocity will be 0. Alright, now just think of the third equation, which was V square minus U square equal to 2AS. If I say I want to find out the value of S, do I have the value of V? Yes. Do I have the value of U? Yes. Value of A? Yes. Means this equation can be easily applied here. So S will be V square minus U square divided by 2A. Right? V square, that is a 0 because final velocity is 0. U square is 20 square. So minus 20 square will be 400 upon 2A. So 2 into minus 2 will be minus 2. This gives us 200 meters. So this was 100. This is 200. Total displacement is 300 meters. Alright, these questions are quite easy. But thing is that you have to understand that what is being given to us and which equation will give us the best possible result. Okay, and it's not mandatory that you have to use the same equation only to solve it. Of course, you can use other equations as well, provided they can give you the same result, or provided you have all the required values using that equation. Okay, let's take one more example. This time, let's take an object which is initially moving with certain velocity. It deaccelerates first and then it accelerates. Okay, so see here, let's say a car going onto a highway having a velocity of 40 meters per second. Alright, it deaccelerates minus 2 meters per second for 5 seconds. Then it accelerates with 4 meters per second square for 20 seconds. And you are supposed to find out the total displacement. That how much distance has been moved by the car. This you are supposed to calculate. Okay, so look here. So here we have again two parts are there in the question. First part where the object is deaccelerating and second part where the object is accelerating. So let's first solve for the deacceleration. So using the second equation, S equal to ut plus half at square. Ut factor won't be 0 this time, correct? So this will be 40 multiplied by 5. So 40 into 5, that is 200. Correct? Plus half into acceleration is a minus 2 into time is 5. 5 square will be 25. So this 2 will cancel out. 200 minus 25, which gives us 175 meters. Alright, now the second part. Second part, displacement. Now, see here. For second part, you cannot apply directly the equation. Reason behind you don't know the velocity yet. Right? So we have to find the velocity of the first part first. So V is U plus 80. U is here 40 plus 80. A is minus 2. Time is 5. 40 minus 10 gives us 30. So this 30 meter per second is the initial velocity for the second case. So here U is 30 meter per second. Alright, now we have the value of U, we have the value of A, we have the value of T. So we can find out the value of displacement easily now. Correct? So let's find it. S equal to UT, that is 30 multiplied by 4, that is 120, plus half into A, that is 4, into T, that is 20, T square. Right? So 2 times 2 is 4. This is 120 plus 800, which gives us 920 meters. So in first part we have 175 meters the displacement. For second part we have 920. So what we will do next is we have to add the two, right? So 920 plus 175. So 900 plus 100 will be 1000. 75 plus 20 will be 95. This will be 1095 meters is the total displacement that we are supposed to find. Okay, now in our next class we'll be discussing the back exercise since we are done with the entire chapter, and afterwards we'll be taking the extra questions or the hot question which are important from the examination point of view. Thank you.